All right, so this is 3.5 part 2. So this is still implicit differentiation part 2. Basically, this last little chunk is the derivative of inverse trig functions. So we know what the derivative of the normal trig functions are, meaning like sine, cosine, tangent, secant, cosecant, and cotangent. But what about like the derivative of this arc sine of u, or arc cosine, or arc tangent? What is that right there? Well, basically, these right here, they look kind of weird. If you notice, it's 1 over the square root of 1 minus u squared times du dx. So whatever u is, you have to put that within here and then square. And then, of course, you chain it. Always a chain rule, because we have to derive the u. That's what this du dx comes from. So where did this formula come from, right? Like, how are we getting from this to this, right? It looks pretty nasty, right? How are they getting that? Well, let's say we had y equals, like, how, right? Big how. How in the world? Where's that coming from? Let's say we have y equals arc sine of x, right? Because we want to derive this. If we take the derivative of this thing here, we should somehow get to something that looks like this. How do we do that? It's with implicit differentiation. So without knowing that arc sine, or the derivative of arc sine of x, is equal to this right here, what can we do? How can we solve for this? Well, we know the derivative of sine, correct? Derivative of sine is cosine. So what we can do is we can take the sine of both sides. Now, why do we do that right there? Because we're trying to undo arc sine. We're basically trying to get rid of arc sine. Well, how do you get rid of arc of any kind of trig function? You do its opposite. So the opposite of arc sine is taking the sine of something, or the opposite of arc cosine is cosine. It's kind of like, oh, if I have to, what's the opposite, or what undoes multiplication? Division, right? Or what undoes addition, subtraction? It's the same thing right here. Or like, how do you get rid of a square root? You squared that thing, right? Because the square root and the squares cancel each other out. That's what happens right here. But I was able to do it because I took the sine of both sides. Whatever you do to one side, you have to do to the other. So what does this leave us with? Well, now we have sine of y equals just x. So we're trying to find dy dx, right? That's what we're trying to do right here. Find the derivative, because again, we're trying to go from this to this somehow. So where do we go from here? Let's take the derivative of both sides. Okay. Now, if we do that, how do we derive the left-hand side? How do we derive the left-hand side right here? Well, this is going to be the chain rule, right? And implicit differentiation. What's the derivative of sine? That is cosine, and of y in this case. But then we have to chain the inside. What's the derivative of y with respect to x? It is d dx, or I'm sorry, dy dx. And all that's equal to, well, what's the derivative of x with respect to x. That's just 1. Now, where do we go? Remember, what do we do in part 1 of implicit differentiation? After that, we went ahead and we isolated the dy dx component. How do we do that? We're going to divide both sides by cosine of y. Okay, so now we have dy dx equals 1 over cosine of y. But remember, we initially said, oh, if we have y equals arc sine of x, dy dx needs to equal 1 over the square root of 1 minus x squared. So we're kind of there, right? We got the 1, but what about the denominator? We need to make cosine of y somehow equal to this right here. How do we do that? Well, remember Pythagorean theorem, right? Y'all remember that? Like we have, I'll say sine squared of y plus cosine squared of y equals 1. Same thing like saying sine squared x plus cosine squared x equals 1, right? As long as these letters match, that's what matters with the Pythagorean theorem. Now, if we isolate this cosine, right, cosine squared, we have cosine squared of y equals 1 minus sine squared y, right? Because I just subtracted sine squared from both sides. Then I can take the square root, right? Or I should, because I need cosine, not cosine squared. In doing so, we now have cosine of y equals the square root of 1 minus sine squared y. So we're almost there, right? We are almost there. So now what I'm going to do is I'm going to say dy dx equals 1 over the square root of 1 minus sine squared y. So we're so close, right? Because this is what the derivative of arc sine of x is right here. We're so close. Look at that. It's just that this needs to somehow become an x squared right here. How can we do that right there? Well, remember, we initially started with y equals arc sine of x, right? We started with that right there. But then we took the sine of both sides. And remember, at this point right here, what did I do? We took the sine of both sides, right? We said, oh, sine of y equals sine of the arc sine of x. And then we got sine of y equals x. That was what we initially did when we first started trying to find out what the derivative of arc sine was. But look, if x is equal to sine y, what if we square both sides right here? That's legal, right? Whatever I do to one side, I do to the other. So what does that leave us with? This says, oh, x squared is equal to sine squared of y. Where else do we have a sine squared of y? Right here. Look. So instead of me saying 1 minus sine squared of y in the denominator, we can say 1 minus x squared under that root. Where did that x squared come from? Because look, x squared is equal to sine squared of y, just from these steps right here. So that's where they're getting the derivative of this arc sine of x, this. Do you need to remember all this work right here? No, you just need to remember the formula, okay? But it's the same step to get any of them, or to derive arc sine, arc cosine, arc tangent. So remember, we said that going back, we have d dx of arc sine of u. That's equal to 1 over the square root of 1 minus u squared du dx. We also have the derivative of arc cosine of u. That's equal to negative 1 over the square root of 1 minus u squared times du dx. So very similar to sine, right? It's just that it's negative. And then you also have the tangent as well, or arctan. So d dx of arctan of u, that's equal to 1 over the square root. Oops, no square root this time. It's just 1 over 1 plus u squared times du dx. This one has no root right here. So for practice, if you wanted to, you could derive these two, and you should get to the same answer. It works the same exact way that we did this one right here. Same exact steps. So how do we apply these three formulas, right? Like, let's say you wanted to find, like we have y equals arctan of 3x. And we want dy dx. How do we do that? Well, you got to figure out what's the u, right? What's the u in all these cases? It's the stuff trapped inside of the parentheses. It could be anything, okay? It could be 3x. It could be 10x squared. It could be 5x squared minus 6x plus 1. It doesn't matter, okay? That's the u. Once you have that, you just plug it into this formula and you simplify it as much as possible. So we have dy dx equals 1 over 1 plus, and then this says u squared. So we have to square that entire quantity. And then times the derivative of u. What's the derivative of 3x? That's just 3. Like that. Now, we simplify it, right? We can simplify a little bit. Meaning I can say, oh, this is equal to 3 over 1 plus 9x squared. Remember, this 3, you're not multiplying to the bottom, okay? It's just 3 times 1 is 3. The 1 times the denominator is that. But then I multiplied out that 3x, right? We squared it right there. Make sure you put that u term in parentheses when you square it, because a lot of people will they'll do this. And I'll say, oh, it's 3x squared. No, it's that entire quantity squared. So you need to make sure that you square everything inside of that thing. So now what if we had, like, say, y equals arc cosine, and I'll say, 3x to the 7th plus 9. Oh, I won't say 9x. Just do something like whatever, 5x. And we want dy dx. So we know we got to use this one, right? What do you do first? Just identify the u. What's the u? It's this whole thing. All this is u. Now that we have that, we just throw it into this equation right here, that formula. So what is that? Well, dy dx in this case would be negative 1 over the square root of 1 minus, and that entire u quantity squared. 3x to the 7th plus 5x, all that stuff squared. And then times du dx. We have to chain it, right? All these inverse trig functions in the end have some kind of chain rule. We always need to derive the u component. So what is the derivative of u in this case? It's 21 x to the 6th plus 5. All right. So what's your final answer? Well, really, you don't want to FOIL this out. The only time you multiply this u squared out is if it would be like one term. Like with the first problem that we did, when it was 3x inside, we said, oh, it's 9x squared. That's fine to square that out. But when you have multiple terms inside, just leave it in factored form. And with this -1, you can distribute it into here if you want, or you can just leave it on the outside. So that is your derivative right here. Now for these formulas, the inverse trig function formulas, I will supply them to you during the test. You'll just have to know how to use them. The biggest mistake that people make again is just they get the u right, but then when they plug it into the equation, they forget to square it. They only square one part of it. Make sure you put that whole entire u term, that whole entire u term inside the parentheses, and you square it, okay? And don't forget, you always got to chain. You have to chain the u. Whatever the u was, it doesn't matter if we're talking about sine, cosine, tangent, or arc, cosine, arc, tangent, arc, sine, any of that stuff. You're always going to have a du dx, right? You always have to chain the inside like that. So that is it for 3.5. Again, here's the bottom right here. I saw that it was cut off.